In this video, what I'd like to do is talk a bit about the sort of patterns we see in functional programming and how we implement those as functions. And what we're going to do in this video is concentrate on lists, because lists are the workhorse and they're a very, very good example of how functional programming gets used over a particular data type. Let's just remind ourselves every list is empty or non-empty, and non-empty lists match the pattern x cons x's, written as x vertical bar x's within square brackets, and that has the effect of matching x to the first element of a non-empty list and x's to the rest. X is the head, x's is the tail. And if we have the list 2, 3, 4, 5, that means the element 2 matches x and the list 3, 4, 5 matches x's. Now the way that recursions, or at least the canonical pattern for recursion over lists, is a template like this. We define the value of foo of the empty list outright, and we define a foo on x cons x's as a function of foo of x's. It depends on foo of x's. And you can see that, we've seen this in practice, that as we evaluate these, the length of the list to which the recursive function is applied gets shorter and shorter until we hit the base case. So we can see the recursion works out. Now the sort of things we saw were things like this. We saw an example of summing a list of numbers. And what we're doing there is taking a list, a collection of elements, and combining them together into a single value in some way. In fact, it's a very general pattern. We've also seen two slightly more specific patterns. One was when we were looking at finding the total area of a list of shapes. What we did as an intermediate function was to define a function that found the area of every list in a list, every shape in a list of shapes. And that was the pattern of applying the same function to every element in a list. And finally, we made a selection from the collection of shapes. The example we looked at was extracting all the circles that were in a list of shapes. So what we're seeing here is a pattern of combining all the elements of a list into one, for example using plus to give some of the list, transforming all the elements of a list, so giving back a list, and in this case we just saw we were using area to give an area of a shape, and finally selecting elements of a list with a particular property, for example the circles from a list of shapes. Now you could, to use the terms that we use, we think of the first thing as being reducing or folding the elements together into a single result. So we fold plus into the list, or reduce plus into the list to give the sum of a list. We call the second operation mapping. So we map the elements, we map a function along a list, applying the function to every element. And then finally we filter the elements of a list with a particular property. And you'll have seen these concepts before in, or you'll have heard of them in frameworks like MapReduce. And this is the same map, the same reduce. So these are the operations that underlie these very complex, very efficient big data frameworks that apply to collections of data and can be implemented in quite sophisticated ways. So what we're going to do next is to take these functional patterns and implement them as functions in Erlang. So that's what we'll do in the next video.